Welcome back to my budget app series, where I attempt to create a personal finance application from scratch and document the process on YouTube. In the previous video, we finished the controllers, and with that the backend service, the initial backend API service, is in a completed state, at least ready to start accepting requests from the client. Before starting to work on the client application, however, I want to set up a development environment with Docker containers, where I can potentially watch and make changes to both the server, the client, have the database running, and the three of them interacting within a single monorepo. Let's jump into the code and I'll show you how I will set up this container environment for development. Alright, so far we've been developing this backend service that is a fastify HTTP server, and the only dependency it had in terms of not node modules or node dependencies but infrastructure dependency was this database, the Postgres database that we started as a container with this Docker compose file. Now we will introduce a web client into the mix, so we need to create a more viable solution for development and deployment in the future. Although now we will focus on development primarily. To do that, my plan is to create a separate, the BW backend service, the budget warden backend service, this repository will stay a separate repository. I want to have one more repo for the web client that will be a Next.js application. So that will be a repository on its own. And my plan is to build a monorepo that will include these two repositories as Git submodules. And it will have a Docker compose file for development that will spin up containers with the backend service, the web client, and the database. And these containers will include watch commands so that I will be able to make changes to both the server and the client, and the database will be running in the background, and I will be able to have live reload and develop by starting a single Docker compose cluster with a couple of containers. So this is the plan. To achieve that, we currently at this stage have a backend service with a Docker compose file. This Docker compose file will have to go eventually, but first we need to include a Dockerfile in this backend service because it will be one of the containers. It currently isn't, we're just running it with this npm run dev command. And I created this Dockerfile. Here I have saved a template for a Node.js Dockerfile so that I don't have to look it up from the web. There are many options to deploy a Node application as a container. This is the most popular one. I'll explain each line here. So essentially, we're using from Docker Hub this Node official image. And we are using version 20 Alpine. Version 20, at the time of filming, is the latest LTS Node version. So this is what I would use for deployment, and in this case, development. Besides that, we're using Node 20, and 20 Alpine means that this will use Alpine Linux, a lightweight distro that is very small in size. Now we are building this Docker image from this image. So anything besides that will include all of the files and configuration this image already has. You can look up reference here. There is a lot to read about this image, but its basic usage is quite simple, to be honest. And this is pretty much its basic usage. So I'll explain what we do as we go on. Next up is the working directory. This is the working directory inside the image, which is a Linux distro. We're basically going to use our app, which is where I decided on the Linux file system that my app will live. You have many options. You can go in the home folder. It's not that important. The only thing that matters is you want to have a clear, concise directory, with a relatively short path ideally, so that you can avoid mistakes and avoid any system directories that are temporary, get overridden, stuff like that. So this user directory, the home directory of this work well. I say it's not that important because this image has a relatively, it's for single use only. Its only point of this Linux file system is to run your application. So if you put it in user or home is not that important in this case. So the next line 3 is copy. This command is used to copy a file or multiple directories and files from your local file system, which in this case is where the Docker file is. So this would be our backend service, to the remote container file system. And notice that I'm first copying package and package walk with this globe pattern. So this will catch package and package anything.json, so these two files. I first copied them and not all files, because after that I will run npm install. As you probably already know, npm install only requires this package JSON. Here we have the specification for all dependencies of the application, and as long as these two files are available, npm install will be able to install all of our node modules. We don't need any of the other files for that. And only after that, I copy the dot means everything, except if we have a docker ignore, it will ignore certain files. So we copy everything to the working directory, user app. So why do we separate that? As you probably guess, we can just move this right here and comment or remove this line completely. We do that for speed. So Docker caches step by step each one of these. And by doing this, if we make changes to the code and we have to rebuild our image, the image of the container application, it will know that this is cached. These files haven't changed. The only reason we would want to rebuild to reinstall the node modules and change the node modules folder is if we change any of the dependencies. And by being able to cache these two steps, the node modules will only change if the package JSON changes, not when our source code changes. On the other hand, if we do this, anytime we do a change to the source files, we will not cache the npm install command, we will not cache the node modules, and our container build step will be much longer, unnecessarily. So it's a very common practice to separate these. This is the optimal way to do it, at least as far as I know. So after that, we copy our entire project. This means all source files, except what we will include in the docker ignore file, which we still don't have. And then we build. This is an optional step because in this case, we're using TypeScript, of course. And the build script, what it does is it runs the TypeScript compiler, which will build our files. That is necessary to run this application. We expose a port. This doesn't mean that 3010 will be the port this application will always run on. Can be overridden by Docker Compose and anything. It's more for documentation purposes that we include this here. And lastly, we have the running command, which is node source index.js, which is not true in this case because after we build the application, we'll get the index.js file in the dist folder because this is how the TypeScript compiler is configured. To output the files in the dist folder. So this is the standard run command. We can override this in a Docker Compose file, etc. So this is basically the Dockerfile of a basic Node application. With this simple Dockerfile, you can deploy a lot of Node applications. You usually don't need the build step if you're not using TypeScript, and you can just run the application after you copy the files and you have all the dependencies. So this is quite simple so far. Now, the other thing we need to take care of is that so far we have a lot of hard-coded configuration here. In our config TypeScript file, we have the port the application is running on, the JWT secret, we have all of the authentication for the database in this data source file as well. So what I'll do is move these to environment variables. To do this, I can use process environment to access environment variables. In this case, this is a string, and the expected port, I just save this file, my Docker file. The expected port by Fastify in TypeScript is an integer. So yes, type number, of course. So I need to parse this to an integer with the parseInt command, that's fine. The port will be a multi-digit integer always. The API prefix, I don't want to be an environment variable. It will be in this configuration. The JWT secret will be. It needs to be for security. So I'll call that environment variable JWT secret. All right. And now we need to make a few changes to data source. And these changes are first, I will move this authentication configuration to this config.ts file. So to export these properties, I don't want to export everything. Type Postgres is unnecessary. The host name I do need. host, port, everything until database. So these properties basically. And here I would make another object called Postgres and have all of these right here. So the host, I'll leave like this for now. No, sorry, that's not true. I need to set this as environment variables. So I'll do pg host, pg port, pg user, and last will be process environment pgdb for the database. Of these will be environment variables, and now I can import config from, let me see, config. Okay, and now I can change these. Config Postgres host, port, username, password, and database. Okay. It's a little bit tedious that we include this from a config file and then include them here. It's just another step, but I like I like having all of the application configuration, essential configuration in a single file. That's why I do this. And here we have an error. Port is expected to be a number, all environment variables a string. So we again need to parse port here to an integer. Done. There we go. So now everything here is an environment variable. We need to configure this, and we will, but not here. Here, what we'll do is remove this Docker compose file because we don't need it anymore. We'll start the database in the Monorepo, and we can, let me see, add a Docker ignore file if we have what to ignore. So get ignore is one thing we don't need. The Docker ignore file should include everything that's not necessary to run the application, essentially. The README, of course, the tsconfig, package walk are needed. So everything else is necessary. Let me see. Is there anything else I care about? Oh yeah, node modules. We don't need to include that. We will essentially install when we copy the application package JSON. All right. This is basically ready for the deployment process. I will push it now, push these changes to the Git repository because I'll use it as a submodule. I'll make a commit. And this commit will be change configuration options to be environment variables and add Dockerfile. And I'll push these changes. Let me see. There are some remote changes. Let's see what they are. Yeah. Probably I forgot something which I had pushed previously. Now these seem to be pushed. Let's open the GitHub repository because we will also need to create other repositories here. But here we have our repository, our Docker file, and now I can actually create the other project, which will be the Next.js front-end web client. I move back to my other directory, my parent directory, which contains BW backend service. That is my dev drive. And here I'll use npx create next app latest to create this web client. And I will call it BW web client. Now it asks me, I want to use TypeScript, ESLint, Tailwind, source directory, and the app router. Basically everything. And I wait for this to bootstrap. Okay, the web client bootstrapped the application. Now I will add this app to my Visual Studio Code as a workspace so that we can see what we have here. So pretty standard stuff. Our tsconfig, tailwind config, these are not that interesting. I'll leave the readme like this for now, the default readme. What I'm interested in at this stage is to add a Docker file to it. And the Docker file will be very similar to my server application. It's still a Node app, this Next.js application. It has a build step, a start step, and yeah, let's do that. Now, Dockerfile stays the same for these lines. we're still using Node 20 Alpine. We're still using the same working directory. We copy the package and package walk JSON files and install. Copy everything, build, expose, default port 80. And here the command to run will be, let's see what, next start. That is the default command for starting after we have built. And now I have my Dockerfile. I need to add the Docker ignore. I will again add the get ignore, the ESLint RC JSON file that is unnecessary. We have what else? The next config is necessary. The PostgSQL config is necessary. The README is not. And lastly, node modules. I need my public folder to be visible. Okay, that is my Docker ignore file here. So now that we have this package ready as well, I'll check the git status. No, I first need to go into the directory, check the status. Let's see what kind of initial commit from create next app. I will add the Docker file and Docker ignore file. Add Dockerfile and Docker ignore files. This will be my first commit. And now I need to create a remote repository for it in GitHub. Let me see. I'll go to repositories, new, PW web client. I will be the owner and it will be a public repository, of course. Here we get a couple of commands to change the branch name, to add the remote, copy this over, and finally push setting the origin remote to the main branch. All right, let's refresh in GitHub and our project is now here. So we have two repositories. Each one has a Docker file, which is used to containerize a Node application. And now we can go on to the step of building our monorepo that will be used for development and potentially deployment. We'll see. To do so, I will make a directory and I'll call it bw monorepo. I will again open that, add that folder to my VS Code workplace. Okay, so this monorepo will have a packages directory. This is frequently used in this normal software file structure when you have multiple software packages in a single repository. And I'll use the git submodule functionality to add a submodule. That submodule will be, let's first add the web client. The order doesn't really matter. Add, you specify the repository and then the local folder. In this case, that will be packages, bw web client. Oh yeah, of course, I need to get in it to create a repository first. Now copy this line. Okay. And now in packages, we get the bw web client submodule. And we get this git modules config file, which specifies our submodules. Let's add the other submodule now. It will be the bw backend service. Okay. Clone, no, git submodule add. And that will go to packages, bw backend service. Great. And I have another submodule. And in my packages directory, if I expand it, I have my backend service and my web client. Now this git submodules, let me demonstrate something. You haven't used them before, which is easily demonstratable if I push this monorepo to my GitHub. I'll call this bw monorepo. And again, it will be public. The same process to push it, change the branch, add the remote, and push. What is wrong? Oh, of course, I don't have a commit. I was wondering, what do you mean it doesn't match any? Just an initial commit and push. Yeah, of course. And we have our packages. Now, if I open packages here in GitHub, the modules are very well annotated. We see the submodule and the commit. This is the specific commit the submodule points to. So this repository has this repository, this monorepo, has packages pointing to a specific commit. That is great. To change the actual commit to which the submodules point, you need to push another commit in the monorepo repository. The good thing is, if you want to make changes to these repositories, now I can cd into the submodule, and here I am in their respective repositories. I can push, and automatically the submodule commit will be incremented as well locally. So I can develop only in the monorepo essentially. Now, as these have their respective Docker files, this monorepo can have a Docker Compose YAML file, which I have also prepared in advance because I will explain it line by line. I will actually not copy it completely. I'll copy it service by service, but it would be very time consuming to type it out in the video and especially look up the reference. I'm not a DevOps engineer, so I have to look up a lot of references and documentations for each line here. That's why I've prepared it before the video to not waste many hours on camera. Now, of course, we start like with the previous Docker Compose file. I will actually now remove the BW web service and backend service folders and leave only the monorepo in my IDE, which is what I will usually do when I develop in the future. Now I will create a docker compose.yaml file. One note here, if I use this repo for deployment, we'll have two Docker Compose files, one for development and one for production. Probably the default one will be for development, and I will have something like pro.yaml or prod.yaml, which will be running the production instance. But I'm not even sure if I will use this repo for deployment. I will probably build another repository specially designed for deployment, which will pull the packages from Docker as Docker images. But we'll see. I might use this repo for simplicity. So we start with the version of the file and specifying services. So the first service right here, I plan to define three services: backend, web client, and database, and then networks and volumes. We'll talk about this. I'll start with the backend service. This is, of course, how I call my service. Here you can basically write anything. I'll call it backend service because this is called bw/backend service, the repository. Bw is the prefix for budget warden, for the branding of the application. Then backend is the environment, not the environment, basically the essential, the essential environment this is running as, and then what it is, a service. So I am just stripping the marketing name and leaving backend service. Because keep in mind, this is also the default host name, which we'll use to reference this as we will be creating a network between them. So backend service is how I call it. You can call it however you want, server or API, anything really. Restart always. You can also specify unless shut down, I think, or something like that. But always is fine in my opinion, in most cases, especially in this case. Depends on database. This will be another service that will start the Postgres database. This just means the service won't start until the database is started, the database container. Environment file. This will parse a file of environment variables that we need to create right here. And in this file, we will specify the environment variables our application needs to run. Plus, I will add a gitignore file and add this environment variables file in it. We don't want to push this to Git, as this will contain passwords for the database. This will contain the port, the host name, everything, basically. And from this environment file, we can set environment variables here. These environment variables are for the backend service container. This is the environment that will be received in the container. And these variables here are received from the .env file that we specified right here. So this backend service port, I need to define right here in my .env file. And this is the environment variable I'm passing as port to BW backend service. So this is the port my Fastify server will run on. So let's change that port to 3010. This is the port I decided to use so far. Let's keep it like this for now. The PG host is set to database. And that is because database is also the host name of the future service we'll build. This is like it's a host name in that network, shared network that I will create. That is a Docker virtual network. And we can reference services that are related and on the same network by their host names. That is very convenient. 5432 is the port. I've hard-coded it because I want to use the default PostgreSQL port here. I don't see a reason to change it with an environment variable because this database will not even be exposed externally for now. It will only be used internally. So there's no reason to change the port for now. At any point, I can change it by modifying the Docker Compose file and adding an environment variable. Next up, we have Postgres user, PG user, essentially. So let's define that as well. I'll leave Postgres for now. And PG, I decided to change this to password, to pass. That's what I used in the server. PG pass. I will leave Postgres for now. Of course, in production, you would want very strong both username and password. Database, I will change to PGDB. Now, this is the database name. So for now, this will be BW for budget warden. And these are the environment variables we need for our backend service. For ports, this is how we usually would define ports. The port on the host machine that is running the Docker container and the internal port of in the container. So for example, this would map port 3010 in the container to port 80 on the host machine. Here I use this environment variable backend service port on both ends so that always the backend service port is exposed on the host machine as well. And now we get to the interesting things that are a little bit more complex. So somewhat. We have two volumes. The first volume is for packages BW backend service, and that is the host machine directory, which is exactly the repository, and its files is mapped to user app on the container. This essentially creates a volume, and the user app contents will match these contents. This allows us to do changes and hot reload in the container. The other volume is of course node modules. This is necessary because after you install node modules, you want the directory to exist in the container. That is standard practice when you deploy node applications with Docker Compose. Something to mention, I didn't mention the build. This is the path to the directory which contains the Dockerfile. That's what we need in order to build this from an image. To build this Docker container into an image. To build the Docker image, and to run the container. Finally, we specify networks, shared network. We are yet to define this network. It's defined at the end of the file. And command. This will override the command in the Dockerfile. And we override it with a nodemon command. User app node modules bin nodemon will execute nodemon with this legacy flag because this uses a legacy watcher that works in a Docker/Windows environment. The newer watcher apparently doesn't work. I had to do some troubleshooting on that. And then we execute tsnode. So as I mentioned, this is Docker Compose file for development. This wouldn't be the command we execute for deployment. It will be the default command, basically. Now, this service, that's basically the backend service. I'll collapse it and go forward with my web client right here. It's much more concise, primarily because it doesn't have so much environment variables. That's all. I'll again collapse the backend. Sorry. Like this. Some white space issues, essentially. So this is the web client code. Okay. The web client code, again, it builds from packages BW web client with each other submodule, and it contains a Docker file. Restart always is the same. It depends on backend service. This is not entirely necessary, to be honest, because the API is used asynchronously. So when the web client starts, it doesn't care if the service is started. I'll actually delete it. It's completely unnecessary. It might just slow down the startup time, nothing else. The environment file, of course, again, it needs environment variables, which is the port. As you can see, I pass a port Next.js automatically picks up process environment port, so I just need to define this web client port environment variable right here. And that will be 80. I want to use 80 as the default for now. Here I again map web client port on the host to the container. Realistically, you might want to have an environment variable for the external and internal ports. In this case, not necessary. And again, I create a volume that maps this packages directory, BW web client, to user app in the container where the files, the project files are contained, and an anonymous volume for node modules, so that we can install our dependencies. It maps to the same network, and the run command is npm run dev, which is again the development and watching command in Next.js. All right, now the next step is of course the database. Let me find that right here. It's very similar to the previous database statement we had, with a few slight differences. We use the Postgres image from Docker Hub. This time we don't specify build but image because we are not building an image locally. Restarts always again, the same environment file, and we set a couple of environment variables, user, password, and db. I have user and password and db. I just need to change this to pass and this to db. Just shorter names. We map a volume this time. Notice here I map a local directory. Here I map an actual named volume. This works similarly. This will create a db data volume, and by mapping it to this directory in the container, I'll be able to persist my database data to this named volume. We'll see it in the Docker desktop app after we run the application. And of course, the database needs to run on the same network so that the backend service can connect to it through this pg host name. And now, speaking of networks, let's define the network. It's actually quite simple. All we have to do is, after services, define a networks block, and we specify our shared network and its driver, which is bridge. That's the default driver for a virtual bridge network in Docker. And finally, volumes. Here's where we define the volumes. We don't need to set up any settings for the db data volume. It's a default volume. We just specify it like this. And this is the entire compose file of the application. Here it is. We have our database, our network volumes, database, client, and server, backend service. This is how it looks like. Have everything specified. Now what we can do is probably start the entire application. Let's test that. I can start it with Docker Compose up, and we get a warning message that the environment variables are not set. Let me see why that is. Oh yeah, so after troubleshooting, I realized I was in one of the submodules directories. So I just need to go to the Monorepo folder and specify Docker Compose up. So at this point, Docker will pull the images for Postgres. It will build my two packages, their Docker images, and after that it will start. Okay, so it took a minute to pull all of the images and build my local images. And we have an error here. As you can see, all of the services have their own walks on the left. And the web client started successfully. The database started successfully after creating the default DB. But the server says it's missing a secret for Fastify JWT. Let's check why that is. If we go to source config, we expect an environment variable JWT secret. And we haven't defined that. We need to define that we need to pass that right here as an environment variable, basically. The same way we pass all of the other ones. And here in JWT secret, I will define just some string like it was before. We don't still need, in production, this should be a secret, probably auto-generated safe string. Now I will stop all of the containers by pressing Ctrl+C. and restart with Docker Compose up. As you can see, all of my images are recreated. The database starts first. Database system is ready to accept connections is an indication that it's ready. And then Next and the backend service start one by one, actually together. And here, my backend service started and my Next.js started. If I test the Next.js service first at port 80, it opens and works correctly. But the server will not work, and I can see why. If I test 3010, it's mapped to 127.0.0.1. We need to set hostname here in the service where we start Fastify to host 0000. This will allow it to bind to anything. I saved and it restarted. So NodeMon is working as well, and now it's working at 0003010. So I can refresh and Fastify is working. Now, one issue we have at this stage is that if I change my client code, let's say I change something in here, in the page.tsx file, is we don't get a hot reload. This is because we need to change something in the next config.js file. I was troubleshooting this, and there are a couple of Stack Overflow questions asked about this issue. We have to set a PO and aggregate timeout to the Webpack config if we're working on Windows and we are running a Linux container, as far as I understand. If you're working on WSL or Linux environment, that is the host system, you won't have this issue. But since we're working on Windows, we need to add this to the next config file. After we do, we can restart the containers. And now we should, let's first see if everything starts correctly. It does. Let's open Post, which is the Next.js application. Let's now change something. For example, get started by editing, edited, save, and I get the compiled message and a hot reloaded Next.js app, which is great. We can edit my server, my client, and start them at the same time for development, which is what I wanted, together with the database. Now, before pushing this, the last thing I want to mention is that you will notice here we have a lot of syntax errors. For example, in the server, console is unrecognized, Fastify. This is because we're missing our node modules. They are not installed in this git submodules. They're an empty folder right now, basically. And in the web client, they're also an empty folder. And to fix that issue, we need to install. To make it easier, I will make this monorepo an npm package that is not to deploy it on npm, but only to have a script which installs the packages for both services simultaneously. And I'll run this script pre-install. So I'll do that with the pre-install hook so that I can run npm install in the root monorepo directory to install the packages for both services. And what I'll do is quite simply cd into packages, bw backend service, and npm install. After that, I'll cd back into bw web client and npm install. And finally, I'll cd back to the root. So this is the script. Let's test it now. Here in the file, we'll leave this to version 1, author, leave the default license. So if I run npm install, the pre-install hook runs. We're getting our backend service installation and a client install. And when it finishes, I have my node modules for my service and for my client. And the syntax errors are gone because TypeScript has its types and everything is working fine. These are of course not necessary in order to run the application at this stage, because I just have I essentially installed the dependencies in the Docker container, but they are necessary because we use TypeScript and we need to know what our modules are. Even if I didn't use TypeScript, I'll get syntax highlighting here that this module doesn't exist. So I need to install these. And with that, the monorepo is complete. I have all of these items here. Let me check my git ignore. I am ignoring the .env file, which is correct. I will add a readme, which will be empty for now. I will fill that off camera, and I can just push it to, I already created the repository, so I can just add commit, and push to the remote. And now my Monorepo is ready to work with. This way, I will be able to develop the client application while my backend service while the database is running, and both are running and interacting each other as they will when deployed, which is very important. These environments won't change. When my application is deployed as a live app, these Node.js services will still be running on Node 20 Alpine, the same environment. All right. With this, I'll wrap today's video. If you enjoy the content, don't forget to subscribe to get notified when another video is released. Take care.